2017, the scientific world was stunned when NASA announced something straight out of science fiction. 7 Earth-sized planets orbiting a single star just 40 light-years away. Using the Spitzer Space Telescope, astronomers confirmed the existence of this extraordinary planetary family around a small, dim star known as TRAPPIST-1. What made the discovery so electrifying wasn't just the number of planets, but the fact that 3 of them lie within the star's habitable zone, the sweet spot where liquid water and perhaps even life could exist. For the first time, humanity had found an entire solar system of rocky worlds that might be capable of hosting life. A tiny star with a big secret. TRAPPIST-1 is an ultra-cool dwarf star, far smaller and dimmer than our Sun. In fact, it's only about the size of Jupiter, yet it manages to hold 7 planets in its gravitational embrace. Because the star emits most of its light in the infrared spectrum, it's invisible to the naked eye from Earth. But for Spitzer, an infrared telescope, it was the perfect target. Scientists used a clever method called the transit technique to detect these planets. Every time one of them passed in front of its star, Spitzer recorded a small dip in brightness. By studying these dips, astronomers could determine the planets' sizes, orbits, and even their densities, which confirmed that all 7 are rocky like Earth, not gaseous like Jupiter. What's astonishing is how compact this system is. All 7 planets orbit closer to their star than Mercury does to our Sun. Yet because TRAPPIST-1 is much cooler, those tight orbits don't necessarily make the planets unbearably hot. Instead, they form a delicate cosmic dance, moving in perfect resonance, a gravitational rhythm that keeps the system stable. The Goldilocks zone. Among the 7 worlds, 3 stand out: TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g. These planets orbit within what astronomers call the habitable zone, the region where temperatures could allow liquid water to exist on the surface. TRAPPIST-1 receives about the same amount of light as Earth does, suggesting that with the right atmosphere, it could have mild temperatures and oceans. TRAPPIST-1f and g lie slightly farther out, possibly resembling colder, wetter versions of our planet, or even icy worlds with hidden subsurface seas. Having 3 Earth-sized planets in a single system's habitable zone is nothing short of extraordinary. Before this discovery, astronomers considered such systems rare, maybe even impossible. But TRAPPIST-1 showed that our galaxy could be teeming with similar systems. Tiny stars with tightly packed families of rocky worlds. Each one could be a potential cradle for life. A different kind of world. If you could stand on one of the TRAPPIST-1 planets, your view of the sky would be breathtaking. The neighboring planets would appear far larger than our moon, hanging in the sky like glowing disks. Some would even show visible surface features. However, life on these planets would be unlike anything on Earth. Because of their close proximity to the star, they are likely tidally locked. One side always faces the star in eternal daylight, while the other side is trapped in permanent darkness. This might sound disastrous, but tidal locking doesn't automatically mean the end of habitability. With a thick enough atmosphere or oceans to distribute heat, the twilight zone between the day and night sides could maintain stable, comfortable temperatures. Imagine a world where the sun never moves, locked in an eternal sunset, eerie but possibly livable. The challenges of a red dwarf sun. Yet there are challenges. Red dwarf stars like TRAPPIST-1 are known to be volatile when young, often releasing powerful solar flares that could strip nearby planets of their atmospheres. Without a protective magnetic field, a planet might be left barren, its water and air blasted into space. Scientists suspect that during TRAPPIST-1's early years, its planets may have faced such radiation storms, potentially losing parts of their atmospheres. However, as the star aged, it quieted down. Now it burns steadily and slowly. So slowly that no red dwarf has ever been observed to die. These stars live for trillions of years, far longer than our Sun, meaning their planets have immense time for evolution. Even if life didn't emerge early on, it might still have time to develop in the future. TRAPPIST-1's longevity turns it into a cosmic incubator, stable, enduring, and full of possibilities. What we know about each planet. The inner planets, TRAPPIST-1b and C, are too close to the star and likely too hot for life as we know it. The middle planets, D, E, F, and G, are the most promising, with a sitting squarely in the middle of the habitable zone. The outermost world, TRAPPIST-1h, is colder, perhaps a frozen sphere of ice and rock. Despite their differences, all 7 planets are roughly Earth-sized, with diameters ranging from 75 to 115% that of our home planet. Their densities suggest rocky compositions, some possibly with significant water content. In fact, scientists estimate that a few of these planets might have oceans containing far more water than all of Earth's combined. A window into planet formation. The TRAPPIST-1 system doesn't just hint at life. It also challenges our understanding of how planetary systems form. In our solar system, the rocky planets are small and close to the Sun, while gas giants like Jupiter sit farther out. TRAPPIST-1 flips that pattern. Its planets are all roughly the same size and closely spaced. This uniformity gives scientists a rare laboratory to test models of planetary evolution and migration. How did 7 similar worlds end up in such neat order around such a tiny star? The answers may reveal how common life-supporting systems really are across the galaxy. The hunt for atmospheres. Finding planets is just the beginning. The next step is studying their atmospheres. Do they have air, clouds, greenhouse gases? These questions are critical to determining if any could support life. When the James Webb Space Telescope was launched, TRAPPIST-1 immediately became one of its top priorities. Early James Webb Space Telescope observations have already revealed that some of the planets, like TRAPPIST-1b and D, likely lack thick hydrogen atmospheres, which means they are true rocky worlds rather than mini Neptunes. The telescope continues to search for signs of carbon dioxide, methane, and water vapor, the chemical fingerprints that could hint at habitability or even biological activity. What's encouraging is that even without large hydrogen envelopes, the planets may still have thinner, secondary atmospheres made of nitrogen, oxygen, or carbon dioxide, much like Earth's. Detecting those is incredibly difficult, but if James Webb Space Telescope or future telescopes spot them, it could be the first real evidence that one of these distant worlds resembles our own. The broader impact on exoplanet science. Before the TRAPPIST-1 discovery, most known exoplanets were giant, Jupiter-like worlds, easy to detect but inhospitable. This discovery changed the game entirely. It proved that small, cool stars could host multiple Earth-sized worlds, making such systems far more common than once believed. Red dwarfs make up nearly 70% of the stars in our galaxy. If even a fraction of them have planetary systems like TRAPPIST-1, the Milky Way could be home to billions of potentially habitable planets. This finding also shifted NASA's exoplanet strategy. Telescopes like Kepler and TESS began focusing more on small, dim stars instead of bright, sun-like ones. The logic was simple. Planets are easier to detect around smaller stars, and those stars dominate our galaxy. TRAPPIST-1 became a cosmic template, a symbol of how ordinary stars can host extraordinary worlds. What comes next? The story of TRAPPIST-1 is far from over. In the coming years, the James Webb Telescope and its successors will continue analyzing these worlds in exquisite detail, searching for chemical signatures in their atmospheres. Missions like ESA's Ariel and NASA's Future Habitable Worlds Observatory are being designed with discoveries like TRAPPIST-1 in mind. Each new piece of data will refine our understanding, not just of these planets, but of how common, life-friendly worlds may be. While no spacecraft will visit TRAPPIST-1 anytime soon, it remains one of humanity's most promising frontiers. Its distance, about 235 trillion miles, is vast, but in cosmic terms, it's practically in our neighborhood. If one day we develop the technology to send robotic probes to nearby stars, TRAPPIST-1 would be among the first stops. A hopeful glimpse into the cosmos. TRAPPIST-1 is more than a scientific milestone. It's a reminder of our place in the universe. A single faint star, barely bigger than Jupiter, hosts 7 rocky worlds, some perhaps with oceans, clouds, and atmospheres. If life can exist there, it suggests life might be everywhere. Even if these planets turn out barren, their discovery proves that the universe is filled with opportunities for life to take hold. When astronomers look at TRAPPIST-1, they see more than data and numbers. They see possibility. They see a mirror 7 times over reflecting Earth's potential future and our deep desire to know we are not alone. And perhaps somewhere in that dim red glow 40 light-years away, another world is looking back, wondering the same thing about us. And that's the story of TRAPPIST-1, a tiny star that could hold the key to our biggest question. Are we alone in the universe? 7 Earth-sized worlds, 3 sitting in the perfect zone for life. It's like nature itself left us a cosmic invitation. If that blew your mind, imagine what else is waiting out there. So don't forget to like and subscribe to the channel. Stay curious, stay inspired, and I'll see you in the next journey through the stars.